So we've got an integral here, log of tangent x divided by sine squared x, and our parameters of integration are from pi over 4 to pi over 3. Now it's important to check these parameters because this function here is not a continuous function at all. We've got logarithm, which we can't have 0 or negative numbers, so therefore we could say x must be greater than 0 for a start. And here, obviously, sine squared x in our denominator, that's going to give us a 0 if x is 0. So this will apply to all of these. But also because sine and tangent have zeros at different periods along the x-axis, we need to be careful that we don't go into another 0, or with tangent you don't want pi over 2 because that will diverge off to infinity. But our parameters here are pi over 3 to pi over 4, so that's fine. This integral here is continuous in terms of this integrand in this range, so we're free to just go ahead and try and integrate. So now we've cleared that up, we need to now think about how we're going to integrate. Well, we've got tangent x here, so a u sub of that would lead us to a secant squared x, but that's not going to help us with our sine squared x. So here we're looking at integration by parts. So let's rewrite this integral and set it up for integration by parts. So pi over 4 to pi over 3, log of tangent x, so I'm going to write that like that, and then sine squared x, well, we've got sine squared in our denominator, so essentially we've got a 1 over sine squared x, which will lead us to a cosecant squared x. So if I write this now and multiply this like this, I've now got the same integral. So now I'm ready for my integration by parts. So our formula for integration by parts is our integral of u dv equals uv minus another integral of v times du. So that's our basic setup. So we need to pick a term we want for our u and pick a term we want for our dv. Then we've got part of our answer, which will be calculated over the range of integration, and this integral here will also become part of the answer calculated at that range of integration. Now ideally we want to get something in here which we can integrate directly and lead straight to the answer, because we don't want to do integration by parts twice if we can help it. So we've got a u and a du, so we want a term here that's going to be nice just to take the derivative of. So log of tangent x, that looks like the likely candidate, because derivative of log, that's pretty straightforward. So I'll let u equal log of tangent x. So let's put that in a bracket as well. So just to be clear, just make sure that's in there like that. Okay, so now we need a du. So let's take the derivative of this. So the derivative of log always gives us 1 over the input, which is our tangent x. And then by the chain rule, we want the derivative of tangent x, which is secant squared x. That's a standard derivative. So now I can write this as secant squared x. So now my dv is going to have to be my cosecant squared x. So dv equals cosecant squared x. So now I need to integrate that to get v for these two parts of my answer. So again, the integral of cosecant squared x, that's a standard integral. That's going to yield me negative cotangent x. So that's those terms there. Okay, let's give that one a bracket as well. So now I've got my setup now, just to plug this in and set up for integration by parts. So now I've got this integral here, gives me uv, which is part of my answer. So I've got u and v. So I've got negative cotangent of x, and u is log of tangent x. So this is all multiplied together. So that takes care of that. Now our parameters of integration come into play here because we need to calculate all of this from pi over 4 to pi over 3. And then we subtract a new integral, which again, pi over 4 to pi over 3. And we want v du. So our v is negative cotangent x, and our du is secant squared x tangent x. So I'm going to write this like this, and that's tangent x dx. Okay, now this we can calculate out, that's fine, we've got no problems with that. This one here is looking a little bit of a mess, but I see I've got cotangent here and I've got tangent here. So let's just try and break this apart a little bit. Let's just do some little scratch work here. So negative cotangent x times secant squared of x divided by tangent x. Well, cotangent x we know is simply 1 over tangent x. So that can be taking care of that. So now I'm going to have a tangent squared x on the bottom. So let's write it up as that. So now I've got the minus sign still stays. So minus secant squared x over tangent squared of x. Now secant squared of x, we know that's 1 over cosine squared of x. So I'm going to write that in here like this. That's 1 over cosine squared of x. So that takes care of that. And tangent squared x, when it's in my denominator, I can flip that and write cosine squared of x over sine squared of x. And then I just cancel them out and I'm left with 1 over sine squared of x. So all of this is simply 1 over sine squared of x, and not forgetting the minus sign. So let's put that in there as well. So now I can rewrite this part of the integral as minus 1 over sine squared of x. So that's minus cosecant squared of x dx. So 1 over sine squared of x, which is where we started with, which we transferred to the cosecant squared of x, which is what we have done here. And then the minus sign is carried through and gone in front. So now I'll put pi over 4 to pi over 3. Now let's take this off the board. And now let's bring down these calculations here. So now I've got negative cotangent of x times the logarithm of tangent of x, pi over 4 to pi over 3. Okay, well we did this integral here, cosecant squared of x dx. We did this earlier here, so dv was cosecant squared of x, and v was negative cotangent x. So this integral, we've already done it here, so now instead of minus cosecant squared of x, for the integral I can now just transfer that into my cotangent of x. So let's do that on the next line. So negative cotangent of x log of tangent x. And now what I'm going to do is here now, I'm going to put this all in one calculation and put my parameters of integration on the end. So now I've got this here becomes positive cotangent of x, just the integral, but I've got a minus sign here. So now I need minus cotangent of x. And then that's all calculated from pi over 4 to pi over 3. Okay, so now I'm ready now to just calculate our answer to our integral. So cotangent of x at pi over 3. So what is that going to be? That's the reciprocal of the tangent function. So tangent of pi over 3, we know that is square root of 3. So this is simply the reciprocal of that. So now I've got minus, let's give us a bit more room, minus 1 over square root of 3. So that's the cotangent. And then log of tangent of pi over 3. So now I'm going to multiply this by the log of square root of 3. So that takes care of all of that. So this one now I don't need. I've just got negative logarithm of square root of 3 divided by square root of 3. And then I subtract cotangent of pi over 3, which will give me 1 over square root of 3. So that will take care of that. So that's all of this first bit. So now I need to calculate at pi over 4. So now I'm going to subtract all my calculations at pi over 4. Well, tangent of pi over 4, that is simply 1. So the log of 1 multiplied by the reciprocal of 1. So here I'm just going to be left with minus 1 times a log of 1. And then I'm going to have to subtract another cotangent of pi over 4, which is just going to give me 1. Okay, so that's my calculation to work out the answer to my integral. Now, log of square root of 3, we can do better than that. So log of square root of 3, that's the same as the log of 3 to the power of a half. So what I could do is I could bring this half out front. So now I can rewrite this here as, and then using this to use that indice law, I can bring the half out front. So I've got 1/2, and it's a minus because I've got my minus sign here. And then I've got the log of 3. So I can just change this minus 1 to log of 3. So that looks pretty handy. The square root of 3 is going to have to stay. So that takes care of that. Then I've got minus 1 over square root of 3. So that's all of that. And now here, let's see what we got here. A log of 1 is 0, so that all cancels out. And I've got minus 1. So I now need to add 1. So that will go in there like that. So that is the answer to my integral. Now, can we simplify this up any more? I could multiply everything by 2 root 3, or to get 2 root 3 in the bottom. So I could rewrite this as the negative log of 3. Multiply this by 2. So now I can now do minus 2. And then multiply that by 2 root 3. So now I'm going to add 2 root 3. And then that's all going to be over 2 root 3. So that would be the answer to this integral here. Log of tangent x sine squared x pi over 3 to pi over 4. Okay.